Welcome back to the channel. In today's video, we will be diving into the world of bash scripting on openSUSE Linux. Bash scripting is a powerful way to automate tasks, manage systems, and even create simple programs. Whether you are a complete beginner or looking to brush up on your skills, this video is for you. So what exactly is bash scripting? Bash, short for Born Again Shell, is a command line interpreter that processes commands. A bash script is essentially a text file containing a series of commands that the bash shell can execute sequentially. It allows you to automate repetitive tasks, making your workflow more efficient. For example, here is a simple bash script that prints hello world to the terminal. Let's create our first bash script, so follow these steps with me. I already did and open my terminal on my openSUSE system. Go ahead and create a new file using touch command or your preferred text editor. In my case, I will use vi command for this example, but if you are using KDE, still you can use a powerful text editor comes pre-installed with KDE called Kate. Start your script with a shebang line, this one. Let's open the file, see how it looks like. Okay, because it was open in the other session. Let's close this one and we go here. Okay, the first line here is called shebang. It starts with a hash and exclamation mark and /bin/bash. You have to start your script with the shebang line, which tells the system that this script should be run in the bash shell. Then add the following code to print a message. Save the file and exit the editor. Before you can run your script, you need to make it executable. This is done using the chmod command, and in our case here, chmod plus x and the name of the file, and hit enter. Now you can run the script by typing // and the name of the script file and hit enter. As we can see, hello world printed, and there you go. The script runs and prints hello world to the terminal. Let's dive deeper into some key components that make bash scripting powerful and versatile. Lines beginning with a hash are comments and are ignored by the bash interpreter. They are useful for explaining what your script does. For an example, we can open the file hello again, and I can add here print a message. So it is like a comment line before the actual code to tell me what this line will do, or for someone else reading my script to understand what is going on here. This file, it gets ignored by the shell. So if you run the file again, nothing happens. Prompting the user for input and using it within the script is called user input. So let's create another file and we call it user input.sh, and now you guys know the drill. the shebang and /bin/bash. You can take a new line, echo, and to echo a text to the terminal, enter your name, then read space name, and this is the variable where the name that you will write will be saved in. Enter to go to a new line, echo, and now we are going to print another message, which is hello, and the variable, as we said before, to call a variable, to get the value inside the variable, you have to start it with a $sign. But if you are going to deal with the variable name and to assign a value inside it, you don't use the $sign. Okay. Welcome to openSUSE. Okay. So to explain, this script asks for the user's name and then greets them. Interactive scripts like these can make your automation more dynamic. So again, let's save, exit, and we make the file executable. Enter, and we run the file. Now it's asking me for my name, Penguin. So it seems like we did a mistake. Let's open here. Yeah, we put double quote here, and that's it. Okay, let's run the file again. Penguin. So, hello, Penguin. Welcome to openSUSE. Let's talk about variables. You can store, as we said before, you can store values in variables and reuse them throughout your script. Same way we did here. So let's create another file and we call it var.sh. Again, the drill, then bash, okay, and name equal openSUSE echo and hello $sign name to access the value inside the variable name. Okay, save and quit. Let's make the file executable. Okay, var, and let's run it, and here we go. Bash supports if statements, loops, and other control structures, allowing you to add logic to your scripts. So let's clean the screen here, and let's create a new file. We will call it control struct.sh. Again, hash bin bash. Okay, now the syntax of if statements is if and brackets, and you make sure that there is a space after the first bracket and before the closing brackets. You add your expression here, name equal space the name I want, openSUSE. Okay, and means if the name variable, the value inside the name variable equal to openSUSE, you close the expression with this semicolon and you write then enter and write echo welcome to openSUSE. Else This is an if else statement. Echo. The indentation here, okay, you can follow like the Python indentation, which is 4 spaces, or you can use 2 spaces, but make sure to be consistent in one script. Don't mix it. Don't use 2 and 4 to make your life easier when you debug your script later. Okay, so here you are not using openSUSE. Okay, and you close your if statements with if I. So what is missing here is the variable name to test it. So we can try it one time, like we equal here, and let's say Fedora, and save and exit. Let's make it executable. Okay, and let's run it. Okay, we did a mistake again. Let's see. Yeah, as I said, here the space before and after. Okay, bash is very sensitive to the syntax. So let's run it again. You are not using openSUSE. So let's change Fedora and we put openSUSE, and we run it again. Welcome to openSUSE. Reusable blocks of code that make scripts modular and easier to manage. I'm talking here about functions. In bash scripting, you can use functions. So let's create a file called abbreviation for function.sh. Let's enter the same drill, then bash. Okay, the function that you will call it to do something, to declare it, this is the syntax to declare a function. The function name, okay, and close brackets, space, curly brackets, open, and make sure to close it and press enter. Okay, indentation, let's use 4s here, and echo hello, variable here it will be the parameter for this function. Okay, we're still writing text. Welcome to openSUSE. Okay, now the function is declared, so we can call it greet, the function name, space, and you give it the value or the parameter for this function that it will be populated here in this variable. So I can put my username penguin, escape. Let's review our syntax. All good. Save and quit. Again, let's make it executable, and let's run it. And here we go. Hello penguin, welcome to openSUSE. Here we have defined a function greet that takes parameter and prints a welcome message. Functions are great for reducing code repetition. Keep that in mind. Storing multiple values in a single variable. I'm talking here about arrays. Okay, so let's create a new shell script and we call it array.sh, enter hash bin bash. Okay, So now another variable fruits equal to declare an array here. Again, bracket the first variable item, I mean apple, space the second item, space, and the last item. Here in arrays, you don't have to put space before the closing and the starting of the brackets. Okay, so now we are going to identify a loop syntax for to go through these items one by one. So for fruit, okay, in here to call an array and to go through it, this is the bash script syntax. Okay, you call it like that: $, curly braces, and inside the variable name and square brackets, and inside it the add, and you close it with semicolon, space, do this echo I like, and the variable that will be loaded with the item. As we can see, there are two different variables here, fruits, and here fruit. Okay, and you close the for loop with done. Okay, let's save and quit. Let's change here to make it executable, and let's run it. So nothing happened. Let's see our syntax again. Echo I like fruit. Okay, we close it with the semicolon. Fruits, see the variable here. Okay, with spelling mistake. Let's run it again, and as we can see, this script uses an array to store a list of fruits and then loops through each item. Arrays are useful when you need to work with collections of data. Now let's explore some more real world examples where bash scripting can be game changer. We can automate backups by copying important files to a backup directory. So let's say this our working directory here, it's important for us, and we would like to make a copy for it using shell scripting to write a script to do that for us. Okay, let's clean the screen here, and we can open another terminal, and we can create the script outside of this folder. Okay, and we call it backup. Okay, .sh. Again, the drill, then bash. Okay, and we need a variable name. We will call it src for source equal. Here also in the shell script, you can put the absolute path as an argument, or you can let the shell to populate it by giving it the variable home, the one that already identified in your shell environment variables. Okay, so here we know that this folder is under our home directory, so we can say source, make sure to put it between double quotes, $, home, okay, /, and let's make sure about the spelling of our folder here, directory. Let's take a copy and we paste it here. Okay, so this is the source that I want it to be copied to another place. Destination, another variable, equal, and as we can see that the color continue to change when I'm writing the variable name and then I wrote equal, the color already changed. And you can put it in a different place or in the same place. So here is just an example. Okay, so I will copy it to /temp just to show you guys, and here the path you can put where you want to copy your important folder or directory. So I will say temp. I can create another folder or directory under /temp. I will call it backup, and I make this folder to be copied there. But in a purpose for explanation, I don't have to do this here now. I'm just showing the idea. And the command cp-r for recursive, and I write the source and the variable destination. Okay, and after this one finished, I would like to get a message to tell me that the backup already completed. So I can write echo and a message, backup completed. Okay, and again you write save and quit here /temp just to show that nothing there, the folder is not there. Let's make it executable, backup. Okay, and let's run it. Backup completed. So if I check /temp, I can see the folder is here. Can do ls to it too. So the folder got copied there. Okay, we can create another script to automate system updates on openSUSE. Instead of every time you run the same command over and over again, you can create a script to do this for you. So we can create another script here and we can call it update system.sh. Again, hash exclamation mark bin bash. Okay, because I'm regular user and I'm already in sudo group, so, and of course zipper is a package management for openSUSE, and it has to run as a root, a super user. So here we need to use sudo, okay, because we will run the script as a regular user. We need to elevate our permission from regular user to root user, and you write the command zipper to refresh the repository before starting or making zipper to check for any update. Again sudo zipper update, and if there is any update, the default answer, make it -y, means here yes for any questions that comes up to continue the installation without asking me. And after this finish, we would like to get a message that the update is completed. Again, we can write echo and we can say system update completed, and make sure to save and quit. Again, we need to make it executable, and now we can run the script update system and we press enter. Now it is refreshing and we'll continue to see if there is any updates for the system, and after it finish it should show me the message system update completed till it finish, I don't need the file here that I created backup. Let's delete it. All this like kind of review for the normal commands that you can use on daily basis from your shell. Okay, let's check it. Yeah, there was C and some packages to be updated. Okay, so let's finish and we can move on to the other point till it's finished. Okay, let's go again to our working directory. Another example, real world example, is to automate log rotation, to manage log files by archiving and compressing them to save disk space. It is one of the most important things for a Linux admin on daily basis. Okay, so let's create another script called log underscore rotate. Okay, rotate, yeah, rotate, yes. Okay, dot sh, and again the drill bin bash. By default on any Linux machine, the logs for most of the application running on the operating system saved under /var/log with a name of that app. If it is a database, email, whatever, even the Avenger should have a log file there. So here to show the idea, again we need a variable that to save the path of the logs that I need to save it. So log dir. Here for var, it's not saved in our shell environment, so we have to write the full path. So /var/log/ and your app name. Okay, the one that you want to do a log rotate for it. Let's check here. As we can see here, it's finished and system update completed, and we got the message at the end. Okay, so let's continue here. Okay, this rotation for the log files where I want to save it, like an archiving for these log files. So another variable, let's call it archive underscore dir equal var. You can archive it on the same place, front slash at the beginning. Okay, log and your app name /archive. Okay, for the sake of this point, let's go to var space, okay, log, and let's check the logs here. Okay, what about the app armor? We don't have logs here. Okay, what about the audit? Do we have okay, because we are not root. Sudo, we have only one file. Okay, what about zipper? Do we have logs here or not? Only one. Okay, we have nothing here to show. Okay, sudo ls. Let's try the cron, the time service. Nothing there. Okay, nothing there. So let's continue with the example, or maybe we can use this one even if it is one file, but we have to use sudo. Make sure about that. Okay, let's finish the script and then we will see what we can do here. So as we can see that maybe this folder or directory is not there or not created, so you can put your command here, make dir -p, as we said before, -p here for parents. So the path I'm going to give you, the command line make dir, if any of the directory name, okay, is not there, create it on your way. So here I can give the variable name here, archive. So what did that mean here? The make.dir, we will go /var is there, log is there, the app name is there. Okay, archive is not there, it will create it. But let's say for an example, this is not there. What it will do? It will create it. If your app, the underscore name is not there, it will create it. Let's say something happened and the folder log is not there, it will create it because it considered as a parent for the last name, the one that make.dir should create, which is archive. So -p here means anything before archive, if it is not there, created on your way. Okay, so to continue, I want to search for a certain files to make sure that these files will be archived, it's some kind of copying or taking these files and compress it and put it in this place. Okay, so I will say find $, and in this path of log.dir, without the equal of course, if you found the type is F file and the name ends with log, okay, execute the following. Here the dash, execute the following, do gzip, and this is syntax for execution inside the shell script for the command find. Sorry, for the command find, this is how you write the commands, the syntax for this command after execution. It means here, let's close it with the / semicolon. The thing here means that the output of the expression before you do gzip for it. That is the meaning here for the starting and closing curly braces here. Okay, so we will write find again log.dir. Again, if the type is file, the name ends with gz, execute the following. Okay, move what you got to the archive folder or directory, and again we have to close the line like that. So it means here the first line, any file ends with log, do gzip for it. Now the compressing will happen here in the same place. Okay, so and everything here from the second line, again find all the files ends with gz and move it to this path. So after this log rotate finish, I would like to get a message to tell me that it's finished. Echo, like printing in other languages. Logs have been archived and compressed. Okay, this is the message I will get when all these commands finish. So let's make it a practical, and let's say here we can change it for ourselves to suit us, our situation here. Let's see this again. Okay, so as we can see here, we have two files, access log and error log, but here it's not ending with dot but ending with underscore log. So we can tune our script to do this. Instead of dot, we will change it to underscore, just to serve us for the purpose of explanation here and showing the idea. So I would like /var /log / /cups. That is where I would like to do a log rotate for the logs there. So here we can change the first one and put cups. And by the way, cups is the service for the printing on your operating system. When you attach a new printer to your system, this is the service that will control the printer and give you access to it. And here we put cups. Okay, so the folder archive will get. And by the way, we have to put sudo here because we have no access as a regular user for /var /log. Okay, and also for the rest of the commands here, sudo and sudo. Okay, and here instead of dot, we will change it to underlog. So means when you go to the log dir, any file ends with this underscore log asterisk here, means anything, any number of characters or numbers. The thing that we care about is the ending, which is underscore. Make sure that you will compress it using the compression GZ. Okay, so now we finished. Make sure to save, commit the changes and exit. You know the drill. Change mood +X. Here I will go to the terminal and we will change directory to cups. And as we can see, we can list. Yeah, we can list, we can change directory to it, but we have no permission to do writing or create directory or create files. And let's run this script and see what will happen. Logs have been archived and compressed. Let's go and check. Yes. So here what it did, it took the files, okay, because if you guys remember, here the second line that find all the file that ends with G and move it to the archive directory. So now we have the archive folder, the directory that got created. If we do listing for it, see, we can see the two files here got compressed. And like that, you can do it for the application that creating big log files and you would like to save some space from your system. You can use the same concept to help you achieve that. So as we said, this script finds all log files in a place, compresses them and moves them to an archive directory. Automating log rotation is crucial for system maintenance and to make system administrator their life more easier. Okay, so we can go and use another more advanced a little bit script, and we can call it to check disk usage and send an alert if it exceeds a threshold, like a disk space monitoring. We can create a script for that. Let's exit from this one and let's go to a clean terminal, and we can call this new script monitoring, or I will call it system underscore monitor. Okay, .sh. We open the file. You guys should know the drill, the shebang, bin bash. Okay, so my threshold will be 80%. If the size exceeds from 80%, acknowledge me or alert me about what's going on my disk. Okay, so guys, please bear with me on this. I know it's a little bit more advanced, but what I'm going to say here, I will explain it later in another video. So keep in mind, this video is about showing what is bash scripting in general, and to give you like a surface, to scratch the surface of bash scripting. Okay, because bash scripting in itself, it's not that, it's more than this. The opportunities is limitless. Okay, so again, I need a variable to hold my threshold with, as we said, is 80. So I will call it threshold, okay, equal 80. That's my variable. Okay, so and now I need another variable, is usage, and this variable will contain a value of an output command line. How to get an output of a command line in your shell script? Okay, whatever your command is, you start with $sign and between brackets like that. Okay, this is how you get the output of your command, that if you run it, like for an example, now I need to get the output of a command df. This command df, if I run it alone, it will show me the mount points and the spaces, but as you can see, the spaces is in megabytes or bytes. So I want something called a human readable, df-h. It will show you like this. Okay, so this output, I need to do some processing on it, like to take a specific data from there. Okay, so I need to get this output from this command. How to take that is using $sign and between two brackets. So I will write df space front slash and then space pipe, the sign, space grep. Okay, and grep here stands for GNU regular expression, and this is another topic, big topic. Okay, so this grep, or these two things, means the output of df space front slash, which is the root folder. The output from this, I am doing some kind of searching, regular expression to search about something. So I will grep again the root, the front slash. So the output of these two, I will pipe it to another command, is awk space single quote, between the single quotes two curly brackets, space in the middle. I will write print the fifth colon. So to give the exact English of what is AWK, it's a pattern scanning and processing language. Okay, and also it's another big topic. It's like a scripting, a language in itself. You can do many things with AWK and SED. Okay, mainly AWK or GAWK is a pattern scanning and processing language. Okay, the SED, the one that we will use now, you can manipulate files or manipulate data through the shell itself, as you will see here now. So far I will run the command df against the root to show you how it will looks like that. See how it looks like? And if I did the same, grep root or front slash, that's what will show me. Okay, because if there is any other output came out more and doesn't have the front slash, don't take it. I want only the one containing the front slash. So now, so far, these two, df and then grep, will show me this output. Here, this output. Okay? So now the output of these two, give it to this. So let's try it here to the shell so you guys can see what is going on before we run the script. So if I press enter, we missed the single quote here. I press enter. See here, it took the 5th column and show me only 9%. See here, this is the first column. 1, 2, 3, 4, 5. That's the one I want to check it. Okay? And again, the output of this, we will pipe it to SED. Again, to show you the proper identification for SED. SED is a stream editor for filtering and transforming text. Okay, if anyone is interested, I cannot wait for my coming videos. You can go ahead and read the manual. So set space between single quotes, we will put S is for substitute. Do you remember, guys, in my last video about the vim? It's the same thing. S for substitute, front slash. I want to substitute the percentage sign with nothing, and you have to put the G at the end. So here this means you will substitute the percentage sign with nothing. So we can take this and let's put it here to show you guys the output. See here, I only got the 9. So now the variable usage will be populated with 9. Let's continue with our script. I will use the if statement. If square brackets, don't forget the space at the beginning and the space before the end. Here I'm saying if usage greater than the threshold, what will happen? Then echo warning and disk usage is above, and the variable threshold. Okay, and you can put the percentage sign here, and you can write like a recommendation: consider cleaning up. Okay, else here, else what to do? Echo disk usage is under control. Okay, and don't forget to close your if statement with fi. So this script checks the disk usage on the root partition and warns you if it's getting too high. Such monitoring scripts help prevent system failures. So let's give it a try, and we run it and we see what we will get. Okay, again, don't forget to make it executable, system monitor, and let's run it. And here, disk usage is under control. Automate scripts to run at specific times using cron jobs. It is one of the services that comes with any Linux, the cron shop, that a service on your operating system checks according to your configuration, check the time and the place of the script that you want to run, or your program, or whatever you want to check on a periodic time or according to a state. It depends on your configuration. Okay, so as we said, automate scripts to run at specific time using cron jobs. So let's take an example to show how to do that. So let's say I'm going to create one that will print a message. Okay, and we will call it midnight.sh, and again bang shebang bin bash. Okay, and I will just print echo this script runs every day at night. Every day at night. Okay, just to midnight. Just a message. Okay, I don't have to yeah, of course, as usual, we save it and commit, escape, and write and quit, and don't forget to make it executable. chmod +x. Okay, to schedule this script to run every day at midnight, you can add a cron job like this. Okay, I will show you again here. Now we are a regular user. Okay, you can run cron jobs as a regular user, or you can run it as a root. If you would like to run it as a root, or at some kind of condition like when the system gets reboot, you put it in this file, cron tab, in this file. Okay, so let's take an example. Okay, permission denied. We need to have sudo to look at it. See, nothing there, some variables identified there, and an explanation about how to put your timing. We have one here. This thing runs every 15 minutes. Okay, so you can put it here, or we can do cron tab. You run the command cron tab as a regular user. It will be identify in your environment, and here cron tab. Yeah, I just missed the option. As you can see, guys, that the command, if you just press enter, it will gives you the options like here -L to list your own cron tab, no cron tab for penguin. Okay, so now I want to add a new one. I use cron tab -E, because if you see here, edit user cron tab if you want to delete, and as we said, my -L for listing, and the list goes on. Okay, so I hit enter. It took me and open a new file in /temp, and here we said midnight 0 space 0 and asterisk space asterisk space asterisk, and the path of the script that you want to run here, pwd. And by the way, in cron tabs you use the full path. Okay, it's not recommended to use any kind of variables. Okay, because cron tab will not understand it. It will try to evaluate it as a path, and the $sign will make a problem for cron tab. So you always use the full path of where your script is. Okay, and what is the file we created? user input system monitor midnight. We called it midnight. Okay, and make sure to save. Here cron tab, installing new cron tab. Okay, so if I did cron tab -L, now I can see that I have a cron tab for my regular user, and at midnight this script will run where the outputs will be logged. We didn't say where, so it will be logged in the system logs. Okay, you will find a file that's named with the username and the output. You can see it there under /var/log. Cron jobs are perfect for running regular tasks without manual intervention. Okay, so let's move on with more advanced tips and some best practices. To take your bash scripting skills to next level, here are some advanced tips and best practices when you write your own shell script. Let's clean this screen. The first one is set -e. It is for error handling. Like, let's take an example here, and USR inputs. Okay, so I will open this one, USR input. Okay, make it a habit that all your, well, when you start writing a shell script, start your script with this set -e. It means this command causes the script to exit immediately if any command fails, preventing further execution. Okay, so make it a habit for yourself. So here to show you where to put it, always at the beginning of your script before anything, or you can repeat writing it through your script everywhere you care that if there is some kind of error might happen and you want some kind of error handling, you use set -e. Let's create file script. We call it error handling .sh. Again, jmang bin bash. Okay, seems I need a new keyboard. Okay, so I will write set -e, and we can use an example here, like copying a imaginary place, like X, Y, Z, A, B, C, and you copy that to backup. I know I don't have /backup, and we can write here location. Okay, and like I'm writing an script to copy something, backup completed. Okay, successfully. I know it will not be completed successfully, but here to show you that set what it will do. Now I'm trying to copy two paths not exist on my system, so this is an error. So let's say I will comment this one to show you what I mean, and let's make it executable. Okay, chmod +x. Let's run it. See, no such file or directory, but still the last message gets printed, backup completed successfully. It is not what I want. So let's edit the file again and remove the comment, and let's run the file again. See, once the error happens, the script stops. It will not continue any further. So keep that in mind. So using set -e ensures that your script stops if something goes wrong, which is essential for critical tasks. You don't want your script to continue running and there is a big error happen on your system. Okay, another one is called trap. To clean up, the trap command allows you to specify commands that should be executed when the script exits or receives a signal. Let's give it an example, and we call it bi trap example dot sh. Okay, again then bash, and let's trap echo single quote. By the way, if you want to have something inside double quotes, you put single quote, and the other way around. If you used single quote outside, you use double quote inside. So here echo and error occurred. Okay, cleaning up, and this line we ended with semicolon and exit, and we write here variable will be named error. Okay, echo this is a risky operation. Okay, another message here false. Okay, this command, let's put comment here, it will fail. Okay, so let's continue echo. It's just an example to show you how you can use trap to clean up. Okay, you won't see this message because of the trap. Let's exit, commit, save, and let's make it executable. chmod plus x, let's run it. See, this is a risky operation, the second message, because the trap that happened at the beginning, an error occurred, cleaning up. Why? Because of the, let's open it again, the file, because of the false here. Okay, it's like to trap anything happen inside your shell, and then you will print the messages here and the second one. Let's see the output. See, this is a risky operation and error occurred, cleaning up. I hope you guys got it. Okay, because as we said here, this is the trap, the trap message, and here the error message. So here an error happened, so now the error will print this is a risky operation, and the trap command is catch it and as a cleanup and showing you that an error occurred, cleaning up. You can consider it as some kind of error handling also, okay, but in a better way for scripting. So as we said, traps are great for cleaning up resources or providing meaningful error messages. Okay, we already spoke about this before, but let's give another example about it, which is having an output of a command. You have two ways. Okay, let's show an example. Test.sh here, then bash. Okay, the n keep stopping. As I said before, if you would like to get an output of a command line inside your shell script, you have two ways. You can use the backticks, this one. Okay, like if I put here ls, you want to get this output, and I will save it in var equal. Okay, let's run this script and see what will happen, but first let's make it executable. Test. Okay, nothing happened because we forgot to print the variable here, but okay, let's run it. Okay, so the output of the command ls saved in the variable var and got printed with the echo command. The other way that we said, instead of backquotes, because it might be confusing for someone else who is maintaining your scripts, if you are in a big team and writing scripts, okay, as I said before, you use $sign and opening closing brackets. Okay, so in this example I will use let's print the date, and here the command date for printing the date. By the way, also to show date here, that's how it shows when you run the command date. But the command date has an argument. You can go through the manuals and get these parameters to get more with the date command to understand how you can get the output. In my case here, I want to print the year, and this is how you write the parameters for the date command. Dash the month is a small m dash %d. Okay, so now the output of this command will be saved in date, and here I will do echo and say 2 days date is date. Okay, let's run it. Today's date is this. So keep in mind, $sign opening and closing brackets is more readable and can be nested, making your scripts cleaner. That's all for today. We have covered not only the basics of bash scripting, but also some advanced techniques and real-world examples. With these skills, you can start automating tasks and managing your systems more efficiently. If you enjoyed this video, make sure to hit the like button, share it with your friends, and subscribe for more Linux tutorials. Thanks for watching, and see you next time.